Good evening, all. Good evening, children. So, good afternoon. How are you? Can you hear me, children?
Yes, sir.
Yes. Can you see the screen?
Yes, sir.
Yes. So, find the total number of terms in the expansion. Yesterday we have seen, expansion. I mean, construction of the binomial theorem. And next we'll talk about general term. General term. So before getting into the general term, let us have a look at construction of the binomial theorem one more time. Let's see. Let's write the formula. Okay. Construction of the binomial theorem. Construction of the binomial theorem. Let me write in a short way. So look at what was that. If I write a plus b to the power of n, which can be written as what? So nc 0, so a to the power of 0 plus, if you want to write in a proper way, nc 0, a to the power of 1, b to the power of 0 plus nc1 a to the power of n minus 1 into b to the power of 1 plus nc2 into a to the power of n minus 2 into b square and so on, plus ncn into a to the power of n minus n into b to the power of r or n, b to the power of n. Okay, this was the basic expansion. So yesterday we learned. Now by using this we'll be writing general term. By using this we'll be writing general term. So basically, how can we write the general term actually? How can we write the general term? So general term is a very, very simple term. Look at it. Very, very important. Very important. So here, beta, look at this here. For this is my T1, term 1. This is my term 2. This is my term 1, term 2, term 3, and this is nth term. Isn't it? T1, T2, T3, and so on till nth term. So for first term, what is the R value here? 0. For second term, what is the R value here? 1. For third term, what is the R value here? 2. So what is the pattern you are getting here? What exactly is the pattern you are getting? For first term, in R value is 0. For second term, R value is 1. For second term, for third term, R value is 2, and so on. If you are writing nth term, your R value is going to be what? What is your R value? R minus 1, right? If you are writing nth term, your R value is going to be what, beta? Look at this here. For writing here from this. For term 1, what is R value? 0. What is for term 2? What is R value? For term 2, R value is 1. For term 3, R value is 2, and so on. Now look at this here. So for R plus 1th term, okay. For TR plus 1th term, what is R value? R is equal to or no. Look at this. Now can I write beta? Look at this here. TR plus 1th term is equal to, what is that? NCR, isn't it? If my R for N, I mean for general term, for the last term you say TR plus 1th term, what is R value? R only. Look at this beta here. For first term, R value is 0. For second term, R value is 1. For third term, R value is 2 here. So 1 2 0, 2 2 1, 3 2 2. So for R plus 1, it will be R or not, isn't it? Are you able to understand here? For R plus 1 term, we'll be having rth term. So R value is what? R only. Now here into NCR, I wrote a to the power of n minus R into b to the power of R. How I wrote this? Try to understand this here. Let me explain you again. Look at this. Here R plus TR plus 1, R value is R. And look at this here. A, what's happening here? A, n minus R. Isn't it looking like n minus R? Look at this here. What is here? N value is 0, right? So a to the power of n minus r. What is r here? 0. So plus, I'm writing only a part. I'm talking about a part. Now look at a here. A n minus, what is r here? 1. So 1, n minus 1. So that's what I wrote here for a to the power of n minus r. Now b is what here? B to the power of 0, b to the power of 1, b to the power of 3, b to the power of 4, b to the power of till b to the power of n. So that's how the pattern is following here. Now if I write beta, look at this. If you observe this properly, if I write this a to the power of n minus r, and next of course it will be b to the power of r or not? Of course b to the power of r. Why? Because look at this. I told you beta, if I add the variables powers, variable of power of the a variable and power of the b variable gives you what? Power of the what? Power of the binomial expansion. So that is what it gives me. So now look at it. I need power of the expansion. What I need? General term for what? General term for a plus b to the power of n. We are writing general term for this is my general term. Hope it is clear. Understood my point, guys? What is the general term of the arithmetic progression? We learned in arithmetic progression, right? A plus d, a plus 2d, a plus 3d, and so on, a plus nd. Okay, so this is my term 1, this is my term 2, this is my term 3. That is how we used to learn. That is how we used to solve the problem. That is how we used to identify that term 1, term 2, term 3, term 4, term 5, and so on. So beta, you can say a1, a2. A1 is what? First term. A2 is what? Second term. Or you can say t1, t2 also correct. Isn't it? I'm denoting with the t1, t2, t3, t4 is nothing but term 1, term 2, term 3, term 4, and so on. That is how we are representing that. And for that, if I ask you to write a general formula of particular expansion, which is a plus b to the power of n, that is ncr a to the power of n minus r into b to the power of r. This is what the general term formula is going to be. Hope it is clear. Any doubts? Any doubt, guys? Guys, look at this here. From this itself I'm writing. Look at this. From this terms itself I'm writing the general term formula. If you observe the pattern exactly, you will get to understand what exactly I'm trying to say. Isn't it? But I look at this. If I add these two, plus r minus r will be getting cancelled. I will be left with what? A to the power of n or not? Yesterday I told you, beta, sum of the variable powers gives you the power on the binomial expansion. Sum of the power of the variables, which is equal to power on the binomial expansion. This is the general term. Okay, understood my point? Understood. This is general term formula. When do we use this general term formula? What is the basic use of that? We'll be looking into the question. Now, without any delay, let's get started with the questions. Let's see how the questions of this binomial theorem is going to be. First, let us start with the basic questions. Then we'll go for advanced level questions. Okay. The first question: find the number of terms in an expansion x square plus x to the power of 13. What is the number of expansion? I mean, number of terms in this expansion. What is the number of terms in this expansion? Tell me. Yesterday I told you, beta, number of terms in the expansion is what? If power is n, I'll be having n plus 1 term. That's what I told, beta. Isn't it? So what is the power here? What is the power you have? What is the power you guys have here?
13.
13. So what number of terms is how much now? Total number of terms is equal to how much? Beta, if my power is
14.
n, my power is n, then n plus 1 terms total I'll be having.
13 plus 1.
So here total number of terms 13 plus 1, which gives me 14.
14.
Very simple. Why you are thinking this much to give the answer of this simple question? Next question. Let us solve this. 101 to the power of 4. 101 to the power of 4. How can you solve this? 1 second. I think it's why it's blinking. Solve this. How can we solve this? Guys, how can you solve this? Don't multiply 104 into 104 into, so 101 into 101 into 101 into 101. Don't do this. Everyone can do this, but guys, by using binomial expansion, how can you solve this question? 1 second, guys. Why it is blinking actually? Let me. So how can we use this binomial theorem, binomial expansion concept to apply in this question? So 101 to the power of 4 given to you. So how can I write this? This can I write this as 1 plus 100 to the power of 4. 1 plus 100 to the power of 4. Can we write or not? So isn't it looking like now a plus b all to the power of n expansion? I know that nc0 a to the power of n b to the power of 0 plus nc1 a to the power of n minus 1 into b to the power of 1 plus nc2 into a to the power of n minus 2 into b to the power of 2 dash 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 till ncn a to the power of n minus n into b to the power of n, b to the power of r. B to the power of not r, b to the power of 0. Sorry, b to the power of n only. Okay, this was the formula, right? So look at this. What is a here? This is a, this is b, correct? So substitute now. What is n here? N is this one. So substitute now 4c0 a to the power of 1 to the power of 4 b to the power of 0 plus 4c1 a is what 1 to the power of 4 minus 1 b to the power of b is what 100 to the power of 1. So plus nc2 4c2 into 1 to the power of 1 to the power of what 4 minus 2 into 100 square into ncn, right? Ncn is nothing but 4c4 4c4 a to the power of 4 minus 4 into b to the power of 100 to the power of 4, correct? Isn't it, children? Any doubts? Total I'll be having how many terms? 5 terms. So let us write fully. Let us write all the terms if you want. So 4c3 1 to the power of 4 minus 3. Okay. So next 100 to the power of 3 plus 4c4, like that. Okay, 4c0 is what? 4c0 is 1. 1 into 1, 1. B to the power of 0 is also 1. Correct? So 1 plus 4c1 is 4. 1 to the power of 3 into 100. 4c2 is what? 4c2 is 6. 4c2 is 6 into 1 to the power of 2. 100 square plus 4c3 is what? 4. 1 to the power of 1 into 100 to the power of 3 plus 4c4 is 1. A to the power of 0 into 100 to the power of 4. Okay, so 1 plus 400 plus here 100 square is what? 100 square is what? 10,000. 10,000 means 10,000 into 6. So 60,000. 60,000 plus here 10 cube is what? 10 cube is nothing but 10 lakhs. 10 lakhs into 4, 40 lakhs. 40, 1, 2, 3, 4, 5. Isn't it? Yes. Plus 1 into e to the power of 0, 1, 10 to the power of 4. 10 to the power of 4 is nothing but 10 crores. So 8 zeros, 8 zeros, 3, 4, 5, 6, 7, 8. Okay. So this is how we can write. So now add all this now. If I add all this, what I'm going to get? So let us add all this. Let us add all this. How much? 1, 4, 0, 1, 6, 1, 2, 3, 4, 5, 6, 4, 1. Add all this. How much answer? What is your answer is going to be now? This is what my answer is going to be. 10, 0, 4, 0, 6, 0, 4, 0. Sorry, here 1, 1, 2, 1, 2 is not 0, 2 only. 2, 0. That's it. So 4, 0, 1. Any doubt, guys, till this? Any doubt till this? Any doubt, guys? One zero four 06 04 0 01. Here 401, guys. 01. It should be 01. So let me write direct answer. Here 1, it should be 401. Isn't it? So 401 plus 6,000. So 60,000. So 60,401. So yeah, your units place will be 1 only. Correct? So this is what your answer is going to be. Any doubt, children? Any doubt, guys? This is what your answer. Any doubts, Anjali ji? So next, 98 to the power of 5. How can you write this? But you write like this: 100 minus 2 to the power of 5, and simplify as per the formula. Okay, it's a very simple question. Please do solve this. So homework. Next question. Let me give the question. Root 3 plus 1 to the power of 4 into plus root 3 minus 1 to the power of 4 is a and dash rational number. Irrational number. C. Negative number. D. None. Okay. This is what question. Make it fast. Make it fast. Let's see how many of you are going to write this. Quick, quick, quick. I'm going to give the 1 minute of time. Make it fast. Let's see who is going to give the first answer. Quick. Guys, what happened? Are you not able to apply here? Children, are you not able to apply? What is the problem? What is the answer? What is the answer, children? Anjali, Pravalika, Tanish, what is the answer? What is the answer? See, first of all, let me expand this. Let me expand this. Both are having same A and B values. A value is root 3 here. A value is also root 3 here. Here B value is 1, B value is minus 1. So in the second expansion, in this the first term, whatever you have, here you have to apply normal formula. Here you have to apply A minus B all to the power of n formula. Alternate signs you will get it. All right. So write this. First of all, 4C0 root 3 to the power of 1, 1 to the power of 0. Next 4C1 root 3 to the power of 2 into 1 to the power of 1 plus 4C2 into root 3 to the power of 3, 1 to the power of 3, 4C3 into root 3 to the power of 4 into 1 to the power of 4, 4C4 into root 3 to the power of so 1, 2, 3, 4 root 3 to the power of sorry here. Oh my god, I wrote ulta. Powers of A, look at this here. Powers of A is 4 here, 3 here, 2 here, 1 here, 0 here, 1 to the power of 2 here, 1 to the power of 3 here, 1 to the power of 4 here, plus next 4C0 root 3 to the power of 4, 1 to the power of 0, minus 4C1 root 3 to the power of 3, 1 to the power of 1, plus 4C2 into root 3 to the power of 2, 1 to the power of 2. Next minus 4C3 into root 3 to the power of 3, 1 to the power of 3. Next 4C4 root 3 to the power of 0, 1 to the power of 4. Now check, look at it. This will be getting cancelled now. This will be getting cancelled. So what you're going to left with now? 4C0 root 3 to the power of 4. 4C0 root 3 to the power of 4, how much? Root 3 to the power of 4, how much, beta? What is the answer? 9 or not? Look at this. Can I write like this? Root 3 to the power of 4 can be written as root 3 whole square. Can I cancel like this? 3 square is what? 9. So root 3 to the power of 4 is what? 9. So 4C0 is 1 into 9 into 1 plus 4C2 answer is 6. Root 3 square is 3 into 1 plus 4C4 is what? 1. 1 into 1 into 1 plus 4C0 is what? 1 into 9 into 1 plus 4 is 6 into 3 into 1 plus 1 into 1 into 1. Correct? Any doubts? So 9 plus 18 plus 1 plus 9 plus 18 plus 1. So how much here? 19. So 28 plus 28. So which gives me 56. 56 is a rational number. Rational number is your answer. Option A is correct. Any doubts, beta? Koi doubt? Any doubts? Children, any doubts here? Here, all you need to remember is because here normally you'll be getting all positive signs. Here, alternate signs. Alternate signs. Clear? Any doubts? Any doubts, people? Guys, are you here or not? Any doubts?
No, sir.
Next question. The total number of terms in the expansion. In the expansion of x plus a to the power of 51 minus x minus a to the power of 51 After simplification is dash. $25. So total number of terms in the expansion, total number of terms in the expansion of this one. How many terms? Total here I'll be having 52 terms. Here also I'll be having 52 terms. Isn't it? Isn't it, beta? So 52 terms I'll be having. So 52, in 52 alternate signs will be getting cancelled. Alternate signs will be getting cancelled, isn't it? Guys, are you able to understand? Here this will be distributed as about 26 and 26 terms. Total 52 terms or not? In that expansion, total I'll be having 52 terms here. Here also 52 terms, minus 52 terms. Okay. So this 26 terms, it will be distributing as 26 terms and 26 terms. Okay. Understood my point? Huh. Here 26 terms, 52 terms. From the 52 terms, half of the terms will be getting cancelled. Half of the terms will be getting cancelled or not? Guys, half of the terms will be getting cancelled or not? So I'll be left with only 26 terms at last. So answer is 26. This will be distributing as 26, 26, 26, 26. So total you'll be left with what? 26 terms. So 26 is the answer. Very simple, guys. Hope it is clear with everyone. Any doubt? So basic common sense. If you use common sense, you can answer the question very easily. Okay, half of the terms would be getting cancelled and we left with only 26 terms. That's why I wrote 26. Next question. Find the coefficient of x. Find the coefficient of x in x square plus 1 by x square plus 1 by x to the power of 5. Let me tell you a simple method. Go with A, B. A is to be already has given. A is to be 2 is to be. What is B is to? Guys, what is the answer of this? What is the coefficient of x in this? How do you solve this? Huh? Guys, first of all, any idea? Guys, no one of you are talking in the class. I need a response from you guys. Please do respond in the class. How can you solve this? Coefficient of x, I'm asking you to find out in this question. I need to use general formula here. What all we know here is general formula. So general term formula. What is that? It was TR plus 1 is equal to NCR A to the power of n minus R into B to the power of R. Isn't it? So look at this here now. So n is what here? 5. C R. What is A here? X square. N 5 minus R into b. B is what? 1 by x to the power of r. Correct? Now this can be written as what now? 5cr into x to the power of 2 5 is 10 minus 2r. 2 5 is 10, 2 into r, 2r, isn't it? So into x to the power of what? Minus r. Can I write like this? X to the power of minus r. That is how I wrote here. So now here bases are same. Can I add the powers? 10 minus 2r minus r. Correct? Isn't it, people? 5cr into x to the power of 10 minus 3r. Hope it is clear. So now look at this here. What I need here? Coefficient of x I need. Coefficient of x I need. So we need a coefficient of x. So now look at this. What is the coefficient of x I have here? Coefficient of x I need. So let's do one thing. We need what here? We need coefficient of x, right? So 10 minus 3r is equal to 1. Why? Because coefficient of x is asking. He is asking us to find coefficient of x. If you can I write x to the power of 1 here? X to the power of 1 or not? So now I'm equating this power with the power of this x. Understood my point? This power and this power I'm equating here. So what I'm going to get now? Tell me here. So 9 is equal to 3r. R is equal to 3. R is equal to 3. Perfect. So now look at this here. If we find out r here, now this is my star equation. I need to find out, if I find out r, I'll be getting my coefficient of x. That's it. Look at this here. From the star equation, 5cr into x to the power of 10 minus 3 into 3. 5c3, what is the 5c3 answer now? 5 into 4 into 3 by 3 into 2 into x to the power of 10 minus 9, 1. So 2 ones, 3 3s will get 2 ones, 2 2s. So 10 x to the power of 1 I got. So coefficient of x is what now? 10 is the answer. Therefore, coefficient of x is what? 10 is the answer. Any doubts? Any doubt, guys? Any doubts here? First of all, what I did, I used general term formula. So from that, he is asking us to find coefficient of x. Coefficient of x. X can be written as what? X to the power of 1 or not? So that x, power of the x and power of this x, I just equated. From that I got r value. I just substituted the r value in the star equation. So from that I just found the coefficient of x easily. Hope it is clear with everyone, guys. Any doubts? Any doubt, guys? Next, look at this. Next question. So simplify, very simple question. Simplify. Simplify this. How can I simplify? Very simple. Look at this plus this by using the formula here. All plus all positive signs, here alternative signs. Alternative signs. Okay. So everything will be getting cancelled. Total you will be left with some constant number. Just find out that. Which formula you need to use? Again, a plus b whole to the power of n formula. Okay. So please kindly do solve that question. Now let me give you one more question here. With the coefficient of x square, coefficient of x to the power of minus 2 and x to the power of minus 4 in the expansion of x to the power of 1 by 3 divided by 2 to the power 2 into x to the power of 1 by 3 whole to the power of 18. Here x must be greater than 0 or m and n respectively. Then m by n is equal to dash. Option A 182, option B 4 by 5, Option C 5 by 4. Option D 27. This is JEE mains 2016 question. Yes. Look at this, coefficient of x to the power of minus 2 and x to the power of minus 4 in the expansion of this one are m and n ratio. I mean m and n respectively. Then m is to n is what? M by n is what? How can we find out this? I'll give a hint to you all. Again, you use the general term formula. You'll be getting two R values. You'll be getting two R values in case 1 and case 2. So take those two R values, substitute in the TR plus 1. Substitute in the TR plus 1. TR plus 1 is what general term formula here? 18 CR NCR x to the power of 1 by 3 all to the power of 18 minus R into 1 by 2x to the power of 1 by 3 into R. So if I simplify this, beta, if I simplify this, you'll be getting one